Welcome guys, hello, this is Mr. Cirillo. I will show you how to draw the shear and the moment diagram. And here we have problem 7.1 on page 341. It's similar to the homework we had, homework 8. So we have this 1/4 10K pressing on a single supported beam, okay? And every time you have a static of strength of material problem, the first step is always to draw a free body diagram. And the second step is to calculate the reaction force at the support. And step 3 is to calculate shear and bending moment along the beam, okay? So here, the free body diagram, you got the free body diagram that I had here. So we have here, we have two forces, one acting on X direction, the other Y direction. And here you have only one force is on Y direction. And how we calculate the reaction at support is to use three equations. Summation of force at X direction, summation of force at Y direction, and summation of the moment on each support you have to give you 0. But because we have only one force here, X, AX, so the value is 0. AX is 0. That's why we just didn't take into account summation of force at X direction. So let's calculate the reaction forces. So if summation of the force at Y direction is 0, I have AY plus BY. So AY is positive. The convention is that force upward is positive, downward is negative. And moment clockwise is negative, counterclockwise is positive. So AY plus BY minus 10K, minus because 10K going downward equals 0. And then AY plus BY equals 10K, if 10K go the other side. Okay, so summation of force at A equals 0. You can take it summation of force at B. The answer is gonna be the same. So like we say, from A here, we have 10 moving clockwise. That's why I have minus 10. And what's the moment? Moment is the force times the distance. Moment is always the product of force and distance. So my moment is moving clockwise to the support A. That's why I have it minus, and the distance is 6, okay, plus BY, Y plus because BY is moving counterclockwise from this point A here. And the distance is 10. 6 plus 4 give you 10. So BY times 10 give you 0. If you solve this, you find that DY is 6K, okay? And because AY plus BY is 10, if BY is 6, so AY need to be 4, okay? Oh, that's how you get my force of reaction. Having your force of reaction now, you need to go to step 3 to calculate the shear force and moment, bending moment along our beam. And how we do that? We do that by having a cut, imaginary cut, okay, from A to C, and another imaginary cut from C to B. So we are studying the behavior of the shear and moment from A to C, and then from C to B. And it's gonna be down from 0 to 6, and from 6 to 10, okay? So for here we have a 10. So section AA, where we have our cut, that's why I have here. So I have my force 4K, that is right there, and the cut AA is right here. So when I cut it, I have my V force, that is the shear, go down, because here it go up, and the moment around, that's the bending moment, Why? Because every time you have a force pressing on a beam, the beam have to bend. That's why they call this bending moment. Okay, so and how you calculate the shear by the summation of force in y direction equals 0, and moment, the bending moment, you calculate the summation of force around the cat equal, it have to be 0. Okay, if now I have my cat here, what I have from summation of force at y direction is a 4, because 4 going up, plus v, sorry, is a 4 going up minus v that go down equals 0. So v is 4k. So we know that from 0 to 6, my v is 4k. Shear is 4k. Okay? And the summation of force at my cat AA equals 0. You have minus 4 times xy, because 4 is moving clockwise around the cat. That's why I have minus. And the distance is x. Okay? Distance is x plus m. You know, the convention say that is plus equals 0. So if you calculate here, moment is 4x. And if x is 0, m is 0. Okay. If x is 6, m, the moment is going to be 4 times 6 here. This equation here. 4 times 6 give you 24. So I know at point 6, sorry, at the distance 6, my bending moment is 24k. So you go down again to section BB. Section BB here, okay? So we cut here. So I have everything else here. I have 4k, I have 10, and I have my cut. That's why I have here 4k, my 10, and the cut. But for what's the distance from A to the cut? I don't know it. That's why I have x. But I know the distance from 10 to A. Give me 6. Okay, so we do the same thing like we did from for 0 to 6. Here is from 6 to 10. So summation of force at the y direction is 0. I have 4k. Why? Because 4 go up, down, go up, upward. Minus 10k, because 10k going downward, and plus v equals 0. That's what I have here. So if you saw we get this, you're gonna find that from 6 to 10, v is 6k. Okay, and for the moment we do the same thing like we did here. So 4 going up, moving counterclockwise, time the distance. That's the moment. So that's why I have minus 4x plus 10. Plus 10, this force here. And by this force is moving counterclockwise around the cut. That's why I have plus. But what's the distance from here to there? It's x minus 6. That's why 10, I have the distance x minus 6. And plus my m equals 0. And if you solve this equation, you're going to see that m is 60 minus 6x. Okay? So now, if x is 6, why? Because we're starting from 6 to 10. So if x is 6, m is 24. So 6, if you replace 60 minus 6 times 6 is 36. 60 minus 36 give you 24. And look, see that from x is 6, m is 24. And the first, in the section AA, we had x equals 6, my m is 24. So if you have if you don't have the same number at the same x equals 6, it means that you made a mistake somewhere. You need to start again. So now, see, if x equals 10, okay, you have m equals 60 minus 6 times 10, and m is 0. Okay, having all the information, now we gotta go and draw our shear diagram and moment diagram. Shear diagram, we have here the V. Okay, shear diagram, this is the zero line, and we say that from 0 to 6 V is 4K. So I go here from 0 to 6, I have 4K. So from 0, I go up 4K. Why up? Because 4K is positive. If we are had minus 4K, I should go from here, I should go down. Okay, I go up 4K, and I'm told that from 0 to 6 is constant 4K till there. But from 6, I have a force 10K going downward. So I have 4, I need to go down 10. Okay, and if here it's 4, I got 6 left. So I go down to 6K. I stop there. And from 6, we had from C to B, or from 6 to 10. Here we had a V is 6K. So we got 6 from here to there to 0 is 6K. Okay, that's how I get my shear diagram. Okay, and moment diagram we do the same thing. From 0 to 6, here from 0 to 6, we had is X is 0, M is 0. That's why I am there at 0. Okay, if X is 6, M moment is 24. That's why I have 24. Because it's 24, it's positive, I'm upward. If it was negative, I should go this way. Okay, that's what I have here, 24. And section B telling me if X is 6, M is 24. X is 6, M is 24. And if X is 10, M is 0. If it's 10, M is 0. That's why from 24, I go back to 0. Okay? So from 0 here, X is 0, M 0. X is 6, M is 24. And X is 10, M is 0. That's why I go 0, 24, and 0. That's how I get my moment diagram. Okay, now check this out. You see the rectangle formed by this shear forces. Okay, here we have 6, and over there we have 4. Okay, if you find the area of this rectangle here, 6 times 4 gonna give you 24. So that's the other way to calculate the moment. The maximum moment is to get the area of either this rectangle or that one. It's gonna give you the same. So over here you have 6 times 4, give you 24. Over here you have 6 times 4, give you 24. This is 24 we have here. Okay, thank you. That's how you get how you draw your shear moment, shear and moment diagram. Now we're gonna go to the next video to see the second exercise. Thank you.